You are watching FinTech Talk, sculpting the future with AI, crypto, and FinTech.
All right, welcome back, FinTech Talkers, where we sculpt the future of FinTech, AI, and crypto. Today's episode is a solo dispatch based on my recent piece, the 5-layer AI stack dispatch from Cisco AI Summit. I published that recently. You can read that at fintechtalk.substack.com. And before we get going, I want to set some expectations. This episode is the high-level synthesis, the storyline, the architecture, the implications. But the full detail, examples, the deeper research, and the layer-by-layer breakdown is in that post. And I'll reference that as we go. But if you want to go deeper after listening, that's the place to do it. So here's the headline. We've been treating AI like the next software wave. But what I heard in that summit and what the evidence increasingly shows is that AI economy is shifting from a software innovation to something closer to an industrial revolution. And as I've written before, the knowledge revolution ushered in by AI is comparable to the printing press moment, somewhere in the 13th or 14th century, which eventually led to the Industrial Revolution, which is how modern society still is, although evolved with what happened during the World Wars, the Information Revolution of the last 50 years, and so forth. So what are the new moats? They aren't just features and distributions. They are energy, sovereignty, and infrastructure. And to understand this moment, I'm using a simple frame. It's a common frame that's used across the industry, the 5-layered AI stack. Energy, chips, infrastructure, models, and then applications. Applications a little wider and broader, but we club it into the topmost layer. Let's walk it. I spent today listening to the Cisco AI Summit, one of those rare stack gatherings where Silicon Valley's power centers show up in one place, all in person, and compare notes in public. Hosted by Cisco CEO Chuck Robbins and President and Chief Product Officer Jeetu Patel, with a lineup that reads like the AI era's cast list. We had Jensen Huang, CEO of NVIDIA, of course, Sam Altman, OpenAI, Mark Andreessen of A16Z Ventures, AWS's Matt Garman, he kind of leads their AI stuff, Google's Amin Vahdat, also kind of comparable role in Google, Microsoft's Kevin Scott, he's instrumental in a lot of the early work that Microsoft did with OpenAI, Anthropic's Mike Krieger, the original Instagram product person, now kind of responsible for Anthropic Labs, which is kind of building the next generation of apps on top of the Anthropic stack, is how I understand his role. Fei Li from World Labs, she's kind of building those 3D, 4D models. A lot of others are building, but she has that World Labs. And a whole bunch of others. Kind of name who's who building on any part of that AI stack that I referenced. And a little bit about Cisco, right? Cisco was the host. Cisco's role here matters. Cisco has been the connective tissue across platform eras. And this event felt like what Cisco does best, convening the stack as we enter something bigger than the internet era, closer to an industrial scale, reshaping of the economy. So what I'm sharing today is my synthesis of what I heard, layer by layer, plus some added research, commentary, and contributions from my friend Dr. Riyadh Hartani, who helped sharpen part of the analysis. Again, I'm going to summarize and interpret here. in this podcast. The full write-up is in the post and worth reading if this episode resonates. I'll put the links, but you can always get to my posts at fintechtalk.substack.com. Let's start with the macro frame. AI is in a sector because it drives everything. The digital economy today, as part of world GDP, depending on how you measure it, is about 15% of the global GDP. Now, the ICT, or the information technology and communication sector, is about 6 or maybe 6.6 to 7%. So the digital economy is almost double because you had players like Uber, Airbnb, and others, many more, contribute. They were not kind of pure play technology play, but they brought in the other parts of the economy, like kind of hospitality and rides and so on and so forth. The same argument applies to the AI economy. AI isn't a sector. AI is a productivity layer for the entire global economy. Think of all forms of labor, and AI can play a role. It can increase the productivity for every form of labor, and that's the real Jensen thesis. He brought it up in the summit, and it kept echoing throughout the summit. AI maps to the whole pie because it'll embed into everything: manufacturing, science, medicine, logistics, finance, education, design, defense, energy, and beyond. And what does this fundamentally do? This creates a philosophical split that you've probably felt too, based on the public discourses on the internet and Twitter and X and so on. One is the dystopian lens: job displacement, labor disruption, the what happens to entry-level white-collar work question. I think Anthropic CEO published, I think, a paper which kind of paints that very dark dystopian view that so much labor will be displaced. But then there's the utopian lens. What happens when intelligence stops being scarce? And that's big. Think about that for a moment. Humanity's biggest problems, like curing diseases, even poverty and things like that, empowering kind of the rural population, you don't have intelligence or kind of labor productivity as a limiting constraint. So that can unleash, so humanity can achieve what took 20 years, 50 years, 100 years for them to build, could potentially be accelerated in like a month, a year, and so on. Case in point is the whole programming use case, right? So by far the biggest success of AI so far, and we're in the early stages, like ChatGPT came out 3 to 4 years ago, is the whole evolution of programming, from the AI copilot to what programming and even design and architecture, it's being done by AI. So I've seen different numbers, but close to 80 to 90% of code written today is written by AI. There's still humans involved, but AI is doing all the hard work or all the grunt work. So going back to the utopian lens, right? What happens when intelligence stops being scarce? And that just unleashes productivity, solves the world's biggest problem. I'm firmly in that second camp, not because I'm naive about the risk, but because productivity shocks reshape society. We've seen this movie before. It's messy, and we, humanity, adapts. There will be misuse, there will be displacement, but bad AI will be countered by good AI. So there will be countermeasures. new institutions, new skills, and fundamentally new possibilities. We talked about it: accelerated science, expanded access to expertise, and abundance in areas that currently feel stuck. And here's the pivot. If AI is the productivity layer for the whole economy, then the winners are not just application builders. They're not just the application builders. Winners are the ones who secure the pipeline from electrons, power, electricity, energy, to the intelligence. That's the core. Energy to inference. And now let's go layer by layer. Layer 1, energy. Power becomes the moat. If you take one thing from this episode, take this. Energy is no longer a line item. Energy is the binding constraint. We're entering an era where power is strategy. The AI boom has turned electricity into a gating factor. Speed to power and certainty of supply determine AI velocity. We're seeing a structural convergence, as shown here in the diagram. Hyperscalers moving upstream into energy. And there's some examples I quote in my article, like Google and AWS or Amazon acquiring energy companies or partnering with them and so on. And energy incumbents, just these are pure energy companies, moving downstream into data centers. Who would have thought that would happen? But AI is making that happen. There's a key split on that energy incumbents, grid versus off-grid. Grid, takes a long time. There's a lot of capital investment, takes a long time to upgrade. Public grids are constrained. There's interconnection queues, transmission limits, regulatory delays. So the fastest path to scale is increasingly behind the meter. Co-locate generation and data centers on the same land, bypassing the grid. It's a lot of off-grid energy production. In the near term, natural gas becomes a bridge fuel for always-on compute, often with decarbonization narratives layered on top. The reason is simple. Solar and wind alone can deliver firm 24/7 power at hyperscale, although Elon Musk thinks otherwise. So he was not there at the AI summit, so we didn't get to hear Elon Musk. But I kind of track him on X, and he kind of talks about how solar is a big thing. And I'm coming to that. We have another point on solar. So solar and wind cannot deliver 27 power at hyperscale, at least not just yet, and not at the reliability curve demanded by AI factories. And the key concept I call out in the piece is the rise of compute utilities. AI giants start to look like energy companies. Energy incumbents, on the other side, start to look like compute platform builders. That is why you see power purchase agreements becoming strategic instruments, and why ownership, market participation, and direct access to generation is becoming part of the AI supply chain. Now, the wildest sub-thread in the energy layer, one that is still early but increasingly serious, is the idea, hold your breath, space data centers. And it's depicted here in the diagram. Not sci-fi. This is not sci-fi, at least as a design space. Stronger, cleaner sunlight above the atmosphere. More consistent solar collection depending on orbit. And then cooling flips. You can't convect heat away, but you can radiate to deep space. It's hard. Launch cost, maintenance, debris risk, networking latency. But the key point is serious people are exploring it. And this was talked about pretty much by all the major players at the summit. And they say it with trepidation that it's still some years out, but they're actively pursuing it as a project. My personal view, if orbital compute becomes viable, it won't replace terrestrial compute. It becomes another tier for certain workloads, and it makes networking even more essential, which is Cisco's home turf. Again, full breakdown and examples are in the blog. This is just the architecture. Layer 2, chips. The bottleneck becomes a sovereign asset. Layer 2, after energy, is chips, and chips now represent hard power. In 2026, compute supply influences the pace of civilization. Chips aren't components. They are industrial policy, capex war, and national security. The 4 big themes in my write-up that was talked about at the AI Summit that I bring up. A, the inference flip. So we're moving from a training-heavy era to an always-on inference era. Inference rewards different physics: throughput for watt, latency, memory locality, and efficiency at scale. In the post, I framed this as a flip. In load mix, inference dominates deployments, and that changes who wins. A good example that I've been talking about separately is in agentic commerce. Think about an instant agent UI. Imagine you're building an always-on shopping copilot where every keystroke triggers, retrieves context, drafts answers, streams tokens, and calls a tool, revise and stream again, and so on. In the training-heavy era, you'd optimize for the best model, the biggest GPU cluster. But in the inference era, you optimize for time to first token, steady token streaming, and cost per interactive session, because you're running this loop millions of times per day. That's where Grok, the GROQ, the LPU, the new chip company, the LPU's first stack is a good illustration of the flip. It's positioned around ultra low latency and high sustained token throughput for serving, which directly maps to the new constraint: interactive UX, high QPS, plus predictable serving. Inference-dominant products rewards architectures that make responsiveness cheap and reliable at scale. So platforms like Grok, optimized for serving speed and efficiency, become strategically important as the load mix flips from train occasionally to infer constantly. And that's the inference flip in the chip dimension. The second point, or B, in chips is that we're entering a bespoke era, custom silicon. The industry is entering a bespoke compute era. Hyperscalers and frontier labs don't want to pay the general purpose tax. Think NVIDIA tax. So custom accelerators and sovereign clusters become standard strategy. This is where compute independence becomes a fiduciary duty. Examples of these are AWS's Trainium, Google's TPU, which has been around for a while, Microsoft's Maya, to name a few. And there are a few other projects that are coming up with this. The third point in chips is kind of decoupling the software lock-in. Historically, the real moat wasn't just the chips. It was the software ecosystem around it. Think CUDA for NVIDIA. But the arc is towards hardware agnostic layers, better compilers, better runtimes, and portability, meaning silicon becomes more substitutable. It's almost like what Java did to the software world. The implication, the single vendor moat weakens over time. A simple example is the shift from Coda to PyTorch. And the last point number D in chips, is the sovereign compute and parallel ecosystem. The chip layer is largely geopolitics. You see that in kind of trade barriers and things. So China is not just a side story. It's a parallel ecosystem. Different constraints, different trade-offs, but rapidly forming a self-sustained stack optimized for sovereign inference. We did a piece on DeepSeek and all last year, and there's a lot of model news coming out of China, and they're doing well. A lot of application news coming out of China. I saw some recently that Alipay or Alibaba is doing a lot of transactions in agentic commerce already. But they're also building a chip ecosystem and an infrastructure ecosystem. They're likely 18 months to 2 years behind. So my takeaway at this layer is simple. In the next phase, the edge isn't just fastest flops. It's the most vertically optimized inference platform paired to energy, networking, and sovereignty constraints. Again, details, examples, and the full reasoning are in the blog post. Layer 3 infrastructure. Networking is the new wall. Layer 3, energy chips. Layer 3 is infrastructure. And that's where hype meets the balance sheet. In 2026, the bottleneck is shifting. It's not just the brain, just the GPU. It's the nervous system. That's the networking, the tentacles. So there's a nice image in the blog that kind of shows this really well. AI clusters create massive east-west traffic. And for those not familiar, east-west is server to server, data center to data center, as opposed to north-south, which is kind of endpoint and consumption to the data center. The faster you scale clusters, the more networking determines how much compute sits idle. This is why networking is back. Why Cisco, Sienna, and others matter again. And this is not in the blog as this happened at the time of my recording this podcast, the summit in India around AI with who gathered in India. Google and others announcing large-scale kind of new redundant pipes, kind of undersea cables from India through the southern route to the US, but through South Africa and Singapore and so on and so forth. We're building extra capacity for the internet. And in a separate post, I'll talk about this, but the Arctic undersea routes also fair game now with the kind of climate changes there. And that's why Greenland's in the news. But this is big, the nervous system, right? AI requires not just the GPU, but the tentacles, the nervous system. So that is why the AI factory is as much about optics and fabric as it is about accelerators, like we talked about in the last layer, the chips. And the second major idea at the infrastructure layer, and this is important, I heard this quite a bit at the summit, the rise of the private AI factory. And you could see some of this panning out. There's this big talk in the stock market, and I've written about this, about SaaS imploding, or SaaSocalypse, or whatever the term is, and potentially impacting hyperscalers. So the argument for the last 10, 20 years was cloud first was the default. But that's getting challenged. Not because cloud is bad, but because for AI, latency and sovereignty can be existential. The analogy I was telling my friend the other day is today, you wouldn't have a big corporation, a big company, a big tech company, which outsources its very moat, the developers, as contractors and consultants. They would like to hire employees. You would like to keep your moat, your human capital inside. AI, infrastructure, the models, and your proprietary training is like the employees of the future. Hence, you don't want to outsource it. You don't want to put that in the cloud. You want to keep it close. And that's where you potentially differentiate. Maybe in the efficiency and the cost, but that's kind of becomes your IP. So the key move is towards a private AI factory, physically secure, terabit scale, designed to keep data and inference pipeline controlled. I heard Jensen, others talk about this. The new topology is energy first. Connectivity is built where the gigawatts are, not where the users are. This is important. That's an important point. That means new terrestrial and submarine fiber routes. We talked about that earlier. It's like the case in point. This was like a couple of weeks ago, but we're seeing announcements on it already. So it proves the point. Terrestrial and submarine fiber routes to link energy hubs to inference hubs. And if you zoom out, this is why I keep repeating energy to inference pipeline. You can buy chips, but you can't easily buy gigawatts and private fiber. That's the moat. Layer 4, models. Energy, chips, infrastructure. Now we're at models. Layer 4, from language to world models. My framing, language was just the interface. It's not the endpoint. The model layer is splitting into two worlds. A few frontier versus a foundational multitude. At the top, a handful of frontier models pushing limits in reasoning and multimodality. Below, a vast and a fast-growing ecosystem of specialized and owned models, many open source, many private, many tuned for specific workflows. This matters because enterprises don't need the best model on earth for every problem. They need their model for their domain on their terms. And the second point here is about this world model and spatial intelligence. As I said, language is kind of the lowest form of fidelity for kind of knowledge transfers. Our reality, well, some will say it's quantum, it's energy, but definitely language is the lowest fidelity form of exchanging information about our reality. The next level from language is obviously kind of visual or 3D or with time 4D models. And that's what a world model with spatial intelligence is. And the frontier from large language models is moving to these world models. Systems that simulate reality, spatially consistent world models. This is the use cases if you think about it. So robotics, physical system simulations, design, biology, think about proteins. Cells are three-dimensional, not two-dimensional. And they're not kind of described, so to speak. You can describe a protein or cell biology or microbiology, but it's best represented in the way it is in three dimensions. The next point in models is the infrastructure mandate. The real competitive advantage is not just model selection, it's owning the inference pipeline. You're hearing that again and again, aren't you? Because if you don't control how inference happens, where it runs, what it costs, how it scales, you're renting your intelligence. I made this point earlier. And over time, renting intelligence is a strategic weakness. This is the age of intelligence autonomy. Layer 4, models. Energy, chips, infrastructure. Now we're at models. Layer 4, from language to world models. My framing, language was just the interface. It's not the endpoint. The model layer is splitting into two worlds. A few frontier versus a foundational multitude. At the top, a handful of frontier models pushing limits in reasoning and multimodality. Below, a vast and a fast-growing ecosystem of specialized and owned models, many open source, many private, many tuned for specific workflows. This matters because enterprises don't need the best model on earth for every problem. They need their model for their domain on their terms. And the second point here is about this world model and spatial intelligence. As I said, language is kind of the lowest form of fidelity for kind of knowledge transfers. Our reality, well, some will say it's quantum, it's energy, but definitely language is the lowest fidelity form of exchanging information about our reality. The next level from language is obviously kind of visual or 3D or with time 4D models. And that's what a world model with spatial intelligence is. And the frontier from large language models is moving to these world models. Systems that simulate reality, spatially consistent world models. This is the use cases, if you think about it. So robotics, physical system simulations, design, biology, think about proteins. Cells are three-dimensional, not two-dimensional. And they're not kind of described, so to speak. You can describe a protein or cell biology or microbiology, but it's best represented in the way it is in three dimensions. The next point in models is the infrastructure mandate. The real competitive advantage is not just model selection, it's owning the inference pipeline. You're hearing that again and again, aren't you? Because if you don't control how inference happens, where it runs, what it costs, how it scales, you're renting your intelligence. I made this point earlier. And over time, renting intelligence is a strategic weakness. This is the age of intelligence autonomy. Layer 5, applications. Agents become the new surface. Now, by far, this is my favorite. I guess a lot of people's favorite. But given the other layers from energy, chips, infrastructure to models, and now to applications, you can see how deep AI is, right? It touches just about everything. But application is where it all comes together. This is where value hits the ground. I'll make a central claim here, and I'm going to say it clearly. The app layer and the previous layer, the model layer, are collapsing. And ties into the other point I made earlier about the SaaSocalypse, and people are debating this on the internet, that it's not, and software will always be there, and so on and so forth. So here's my simple first principle argument. Machines 10, 20, 30 years ago could not interpret human intent, human workflows, how we think, how we structure information, what we want the machines to do. And that's why we had programming languages and compilers and then eventually more abstractions like relational databases or databases and system of records and applications and so on and so forth. But we're now entering, we're not there, we're entering into the world that machines can interpret human language, but conceivably even more in the future, kind of ascertain intent. And especially if you're talking about word models and things, a robot, which can hear, not only parse language, but can kind of see other things. Machines don't need that kind of translation layer. So how this transition happens, we don't know. But my central thesis, is that apps and software capabilities as we know it will merge into these frontier model ecosystem. And that's why I claim that the app layer and the previous layer, the model layer, are collapsing. So think about the OpenAI ecosystem and other, like the Gemini ecosystem or even the Anthropic ecosystem. Maybe those are the frontier models. Maybe a couple of Chinese models are up there as well as frontier models. So then the core model and then kind of an app store type ecosystem around them. So apps won't disappear, but they'll become thinner. Interface, workflow policy, distribution, trust will still be there. While capability, the doing, moves into the model layer and the agent layer. A few highlights I call out in the blog. Coding is the first breakout workflow or application, if you will, where AI is already embedded day to day. Agents push beyond human in the loop as a defensive posture towards AI in the loop of human potential. And this is an interesting point. There's a lot of talk about, okay, in terms of governance, in terms of safety, humans should be in the loop when AI is doing something. I actually flip it, and there was a lot of discussions around this at the summit. AI agents and AI fundamentally are intelligent like human, like you have all these benchmarks saying what they can do and stuff like that. The AI can take a test better than the humans. So when we design intelligent systems or expert systems or information processing system or knowledge system, what have you, whatever system, or any business workflow, why would you design it with the human constraint? That's how we have been. You would design it to leverage the potential of AI agents or what they could do. That's fundamentally what AI in the loop rather than human in the loop means. So you don't want AI to do just about everything. So humans still add value, and then they drive what needs to be done. But you redesign workflows, you redesign business processes. So one of the recommendations I gave on social media, as someone was asking, what should CEOs do? Should they kind of upskill with what's happening in AI? My simple thought was, like, if you're a CEO of an enterprise, you should reimagine that your whole institutional knowledge in systems and systems records, in prior history, and your employees, they're all getting encapsulated into a model, either a frontier model or your own model or a combination, your frontier model adapted to your institutional knowledge. If you had that today, right, all your kind of current and past employees' knowledge of how to run the business all encapsulated in the model, besides all your customer information, everything, all your system knowledge and information, structured as well as unstructured, as we say, then how would you design your workflows? How would you design your customer workflows? How would you design your operational workflows? You would fundamentally do it differently because the intelligence is there. You won't design it based on human constraints. So that's a big kind of paradigm shift in application design, workflow design, and company design. And I know there's some bets going on, especially Sam Altman, about the 1-person or 2-person AI company unicorn, right? So it's who's building a single. I wish I was, and maybe I will, a company that's just one person and a whole bunch of AI doing the work instead of scaling a 1,000-employee company or building a 1,000-employee company. You have one person building some value, some business with a lot of AI workers, and it becomes $1 billion in valuation. And it's going to happen sooner than you think. The other point in apps, and this came out in the summit, AI makes expert generalists. There's this argument that frontier models, can they do mathematical inventions or solve mathematical equations that have not been solved, or in physics and other sciences? Maybe they will, but the value of AI is that cross domain expertise. Think about medicine, think about life sciences. We have PhDs and postdocs who are very specialized, very narrow, very deep, but very narrow. Augment them with the right AI that can connect different domains. So it's like the PhD working with 10 other PhDs in the same room in different domains. And they could solve problems, or they could synthesize across silos, which currently humanity misses. So this could have huge implications: drug discovery, disease management, and so on. So AI will make expert generalists. AI synthesizes across silos, enabling broader competence and higher leverage. So the biggest apps may not be kind of siloed apps, but this kind of across domain apps. And in the app, I think I mentioned this earlier, China is a real competitor at the application and also at the model level. Fast iteration, strong open gravity. But I want to repeat my bold prediction, right? Models and applications will collapse. Big chunk of SaaS is information processing. As models get better at representing intent and operating on information, more of that software gets absorbed into model platforms. The marginal cost trends towards compute and energy. And I've framed it in one of my posts as Patty's Law, but the value add of software will diminish, and it'll equal, the cost will equal to just the compute and the energy that the software needs, because it'll be all kind of GPU and energy. And that's what we're seeing perhaps in the markets. Seat-based pricing is less durable, and it will be challenged in the era of AI. Software becomes embedded intelligence, not standalone products. This doesn't happen overnight. It's an S-curve, but directionally, it's hard to unsee once you see what's being said. Let me land this with the takeaways I'm carrying into 2026. Sovereign AI is the new imperative. Don't outsource the brain. If your inference pipeline lives entirely on rented infrastructure, your competitive destiny is rented too. Energy strategy. The gigawatt moat is real. The winners secure power certainty. Custom silicon is becoming a standard playbook. General purpose compute gets expensive at scale. Bespoke compute reduces cost and improves performance. World models are the next frontier. We're moving from software that writes to software that simulates. The great collapse. Models and app merge. Apps become the interface. Models become the engine. Pricing, moats, and value capture shift. And I'll close with this final line from the piece. The winners of this phase won't just ship AI features. They'll secure advantage across the multiple layers. From the electron to the inference. If you want the complete version with deeper example, the full breakdown and supporting details, go read the full blog post. The 5-layer AI stack dispatched from Cisco AI Summit at fintechtalk.substack.com. And if you're a company that wants to be featured in the future of AI stack research and narrative, post also links to the FinTech Talk Narrative Studio. All right, thanks for listening. This is Patty, and this is FinTech Talk, sculpting the future of FinTech, AI, and crypto.
You are watching FinTech Talk, sculpting the future with AI, crypto, and FinTech.